In this video, we're going to do some practice problems relating to average velocity and instantaneous velocity. So first question has to do with a table of values. The table of values show the position of a small object thrown in the air. Note that at the beginning, we're going to start at 6 feet in the air. We think about this as a graph. We're going to start 6 feet in the air. We're going to throw the ball up, and it's going to come down. And we're tracking the position, how high off the ground we are at a certain time. So, first question is, find the average velocity of the object during the first 6 seconds. So that is the average velocity from t equals 0 to t equals 6. So the answer here is going to be the function value at 6 minus the function value at 0 over 6 minus 0. And the units here are feet in the numerator and seconds in the denominator. So f of 6 using the table is 30 feet. F of 0 is 6 feet. And then we have over 6 minus 0, or over 6. This is feet per second. So 30 minus 6 is going to be 24 divided by 6. This should be 4 feet per second. Now, because it's such a large range of values from 0 to 6, it's the entire flight path, it's not giving us a lot of really good information. It's just telling us overall we're traveling 4 feet per second. If we kind of look at a smaller interval, like we're going to do in the next problem, we get a better idea of kind of what's going on at a certain time. So next question, find the average velocity of the object between 4 and 5 seconds. So let's do f of 5 minus f of 4 over 5 minus 4. And again, this is feet per second. F of 5 is 106. F of 4 is 150. And then we have 5 minus 4 on the bottom, feet per second, which is going to give us minus 44 feet per second. So what does the negative mean? This is a negative velocity, which means the ball is going down. If I asked what the average speed was, the average speed would just be positive 44 feet per second, but velocity gives us a little more information. In this case, we are going down at that point. All right, now let's look at estimating the instantaneous velocity at t equals 1. So we want to find what is the speed at t equals 1. And since we only have limited information here, the best we can do is to estimate it using the value closest to 1. So we're going to use the value closest to 1, t equals 1. And there are two things that we could do. We could use t equals 0. And if that's the case, we have f of 1 minus f of 0 over 1 minus 0, which would be 90 minus 6 divided by 1, 84 feet per second. And that is an estimate for the instantaneous velocity at that point. We could also use the higher value, t equals 2. In that case, we have f of 2 minus f of 1 over 2 minus 1, which is going to be 142 minus 90 divided by 1, which is 52 feet per second. So both of those are estimates for the instantaneous velocity, but what might be an even better estimate is to take the average of those two. So a better estimate is to take the average. Seems like the right answer is somewhere in between 84 and 52. So let's just take 84 feet per second plus 52 feet per second and divide by 2, which is 68 feet per second. We'll call that our best answer. However, 84 and 52 are also acceptable answers, as there's no wrong way to estimate something. Our most accurate is probably the average, and we should do this if we can do it, but we're taking like a one-sided kind of estimate with the other two things. We could also estimate it with using t equals 3. It's just further away, so it's probably a worse estimate. All right. So next example, the graph below shows the distance covered by a moving object. Estimate the instantaneous velocity at t equals 3. So first of all, let's think about what that's going to be. This is going to be the slope of the tangent line at t equals 3. So what we're going to do is we are going to draw the tangent line to the best of our abilities, and then we are going to estimate the slope of that line. We could use average velocities and go that route, but since we can draw the tangent line to some degree of accuracy, we can kind of do a good job here. So here's the special point, a f of a, 3f of 3 in this case, and I'm going to draw a line that kind of hits the function only at that point. So here we go, let's give it a try. We'll call that a fairly good way to do it, even though it's not perfect. Since we're just estimating, it doesn't have to be perfect. So I want to find the slope of that line. I already have 1 point, 320. So I need 2 points on the line, and one I know for sure is 3, 20. And then I'm just going to use another point. Let's use this one up here. That's going to be the point 4 and about 32. I don't know, you could say maybe 33, and if your line is a little bit different, it might be a slightly different value. So the slope of this line, the instantaneous velocity, is going to be about 32 minus 20 over 4 minus 3, or in this case, 12 over 1. So 12, and this is going to be miles per hour based on the units that we are given. All right, so we need some practice drawing tangent lines. We need to draw the line that kind of hits the function at that 1 point and then kind of goes off in either direction. It kind of gives us exactly how much that function's changing at that point. All right, last example, we'll answer some questions here. We have a ball is tossed in the air from a bridge. Its height, y, given in feet, above the ground in t seconds after it's thrown is given by the formula y equals negative 16t squared plus 50t plus 36. And note that this is our function f of t. So in the first example we did today in this video, we have that the function was given by a table. In the second example, we see that the function is given by a graph, and now we're given the function given by a formula. So the first question says, find the average velocity for the first second. That is from t equals 0 to t equals 1. And we know that the average velocity is going to be f of 1 minus f of 0 over 1 minus 0. In that case, that's going to be negative 16 1 squared plus 50 times 1 plus 36. That's plugging in 1 into the function, minus plugging in 0 into the function, negative 16 0 squared plus 50 times 0 plus 36, all divided by, in this case, 1 minus 0, or 1. So simplifying everything here, we have a negative 16 plus 50 plus 36, and we have minus 36 here. We'll cancel out the 36's. We have negative 16 plus 50, which is going to give us total of 34 feet per second. We can do the same thing on a different time interval. So let's do from t equals 1 to t equals 2. Here we have f of 2 minus f of 1 over 2 minus 1. F of 2 is negative 16 2 squared plus 50 times 2 plus 36 minus plugging in 1, negative 16 1 squared plus 50 times 1 plus 36, all over 2 minus 1, which is just 1. So we have negative 16 times 2 squared is going to be negative 16 times 4. That's negative 64. Plus 50 times 2, which is 100. Plus 36. Minus negative 16 plus 50 plus 36. And let's actually distribute that negative right off the bat. So that's going to be a plus 16 minus 50 minus 36. That is distributing this negative to all three terms there. So I have a 36 here, negative 36 there. They just cancel out. And I'm just going to do some simple arithmetic to find the answer here, which is going to be 2 feet per second. Now let's answer the question about instantaneous velocity, or what is the velocity at a specific moment in time at t equals 1. Well, here we're going to use our limit definition of the instantaneous velocity. So this is going to be the limit as h approaches 0 of f of a plus h minus f of a over h. And just note that this is our function, f of t. We have a is going to be the value of 1. That's what we're looking for. So before we get going on this, one thing that we need to go over is how to find f of a plus h. As this is actually one of the biggest issues with this problem, is dealing with that function notation. This is going to be plugging in a plus h for t. So that's going to be negative 16 times whatever t is squared plus 50 times whatever t is, plus 36. We're going to plug in a plus h in for each of those. And note that a in this case is 1. So this limit we can rewrite as the limit as h approaches 0 of negative 16. We're going to go 1 plus h quantity squared plus 50 1 plus h plus 36. That whole thing is f of a plus h. And then we're going to subtract off f of a, which is negative 16. We're going to plug in 1 for t, 50, plug in 1, plus 36. All over the quantity h. So note that what we're doing here is a limit. And there's some algebra that we could do very quickly, and we're going to do that in a second. But note that if I plug in 0 for h, I will always get 0 over 0 when we're doing this difference quotient, this definition of instantaneous velocity. So that's an indeterminate form, which means that I need to do some kind of algebra to simplify this, hopefully cancel out maybe the h's so that I can do this limit. So to see how that might work, let's do the simplification here. Each step of the way, I am writing the limit as h approaches 0. And here we're going to do some simplifications. We have negative 16. 1 plus h squared is 1 plus 2h plus h squared. Here we have 50 plus 50h plus 36. You will write plus 16 minus 50 minus 36. Remember, we need to distribute this negative to each term. Also note that we are distributing the 50 to each term, and we're expanding out the 1 plus h squared. And all of this is over h. One more bit of simplification, and then we can kind of really get going. Let's distribute that negative 16 into each term. So overall, we have negative 16 minus 32h minus 16h squared plus 50 plus 50h plus 36 plus 16 minus 50 minus 36 all over h. And note that there's a lot that we can cancel out here. We have a positive 36 and a minus 36, positive 50 and a minus 50. Here's a minus 16 and a positive 16. And then we are left with minus 32h minus 16h squared plus 50h over h. Now, all I've done is simplify. I haven't really done anything algebraic yet to cancel anything out. I still have 0 over 0 in the limit, but now I have an h in every single term, so I can cancel that out, and I am left with the limit as h approaches 0 of negative 32 minus 16h plus 50. And now, when I plug in 0 for h, there's no issue here. I have negative 32 minus 16 times 0 plus 50 is just going to be negative 32 plus 50, which is 18 feet per second. So this kind of calculation is one that we are going to do throughout this chapter. It's an important one. It's finding the limit with a difference quotient. And this kind of process of canceling out the h's in this form is going to be how we're going to go about this.